communication of all LE system or all electronic system. You have to hook up the dongle at CAN B. So for here, you can see they group the CAN communication by their command. So for this one is the MCU control command. Is controlling the MCU, like it commanding the MCU. So you can see the input here is like the motor 1 talk command, motor 2 talk command, the enable mode of the inverter, and the reset signal. And for this one is the pedal module broadcast. Yes, the PM is stand for pedal module. That is also an old term that we inherit from previous generation. So you can see it takes the brake 1, throttle 1, throttle 2, and there is suppose in their old design there is also there is a fourth sensor that's supposed to hook up to this pedal module. Which is Part 2, but since we only use one brake sensor, so the Part 2 is reserved here. And also a error code and a stay code. And also the DCS broadcast. These two broadcasts is not very meaningful for now. We broadcast them for data logging. So the main dish here is the MCU control. So you can see for MCU control we have separate into the left rotor and right rotor by putting them up and down. And for the left hand side is the control command and the right hand side is the reset command. So we can take into this to check. Like for this command we need a torque command and a speed command, a direction command, the inverter enable, and inverter discharge, and the speed mode and torque limit. And why we put all these values that we don't need to use here is because this is how the MCU manufacturer define the control command. So if you click inside, you will see the torque command is converted into an unsigned integer and put into the command and put into the message. And speed command also, although it's just 0. But this is how the command was divided by the manufacturer, so we just follow the structure of it. So in case later on we need somehow we need to use the speed mode, we can easily change the program. And for this block here, they are some predefined function block that I personally like. So it is possible that you can write a library and use it later on in MATLAB, in Simulink. It's possible. But you need to take some time to learn how this library is referenced in MATLAB, because it is, I won't say it's very complicated, but sometimes can bring you some trouble. So if you really decided to write a library, make sure that you test it properly. So you can see here that this, if you click on this block, you can see some predefined value here. Like let's say for this speed command, you have to convert it into a unsigned integer. But for this unsigned integer, you have to do some pre-processing for this word value. Like you have a maximum range, you have a minimum range, you have an offset and a vector. And this is the knowledge that you will need to learn if you want to dig through the campus, because there is something called DBC. There is a file format to describe the CAN message, but for now you don't need to learn it now because it's not the time for you guys to construct the DBC file. But basically, you need to know you will need a lot of this 4 value in the DBC file. So that's why also the board requires this 4 value. If you later on want to deep through on the CAN computation, you will learn the knowledge of this. But this time, for now, you guys only need to learn how to use this library to convert the message. And for the reset message, it's slightly the same, but as you guys can see, we only use the first 3 bytes. So we only have the reset and the read and write flag. This is the part for the CAN communication. So for the control algorithm, it sounds very fancy, but you can see there's nothing here because no one ever write any algorithm in the car. And even anyone had do that, we have no time to do the test. So the control algorithm is empty, and global quantum assignment was useful, but turned out it's just also bring a lot of trouble. So it's also get disabled. And for this method override control, as I say, there is a flag that for us to turn on the remote telemetry feature for controlling the car. And this part is for even more detailed control. Like, let's say we need to control the dashboard, then we have to enable the dash bypass. And to select what signal from the dashboard we want to bypass. And the more detailed setting is inside that feature or inside the input part. So you won't see the details here. But if you want to see, there is one example is like for the dashboard. We have the LTD button bypass, and we have the reset button bypass, and also have the boost bypass is inside another feature. And here the routine is basically the core part of the car functioning. Like we have the brake LED. If you see the .ip, the work in progress, next to any name of the function block, don't mind that. It just is not. Usually, that's not meaning not finished. It just mean we are working on it to make it functional. Or more precise term, we are tweaking the performance. Like this one, for controlling the brake light. So originally you have a brake LED enabled, and turn out we found the rule don't allow us to have additional control on the brake light, so we disable that. So we only check the brake pressure and have a threshold for it. So if the brake pressure is larger than the threshold, then we turn on the brake light. That's it. So it's not still in progress. It's just we finish it, but we think it still has room for improvement. So we keep the work in progress. So even half a year. So even we leave the program half a year. And when we check the program, we can still remember, oh, we can still make some improvement here. Or the work in progress will still check us to click inside to check if we still need to change anything. If you really think the brake light part is finished and nothing to change, just remove the work in progress. For this one, the error and status indicator flag is really still work in progress. This part is really work in progress, and the indicator LED switch. This part was deleted on the dashboard, the dash displays. So still need to do some work on it. And for the ready to drive knowledge, basically the knowledge to enable the ready to drive. So if you have checked the rule, you should know that for entering the ready to drive mode is not just press the button and it turns into the ready to drive. There is some requirement for ready to drive, and here is for checking the requirement. So if you want to learn more about the logic here, you can later on check that. I won't describe too much here. And also the buzzer logic, this for the buzzer sound for the car entering the ready to drive mode. You should also know that if you have read the book. And also the MCU reset latch, and also the conversion for the throttle value to the hot command value is all for this part here. Oh, by the way, for now, you guys may see there is two lookup tables here. These two lookup tables here is previous data for our graduated senior. For my graduated senior, testing the motor at HKPC with their dyno. So this data is useful. But when we try to utilize this data, we find that if we don't have the real RPM sensor, this data is just useless. So we have to disable them here. Turns out if we don't have the RPM value, we can't even turn on the motor. So once you guys have the RPM sensor back, you can try to utilize this RPM sensor and also the lookup table. But there is no guarantee this data will also function properly because we have changed the inverter. We are using different inverter for. They are using, when they do a dyno testing at HKPC, they are using the HKPC brand inverter, which I would say it do the work, but not a very good inverter. It do the work, but not very good. Also, this tool is the Part2 reliability test. And the reason why I need to change it back to work in progress is because I don't know whether they will change the sensor type or the pedal design will change again. So if they change again, you have to modify the value here again. So I change it back to work in progress. So you say you still remember you still need to do something here. And suppose there's basically most of the things here. So when you have a finished version, if you want to try to build a program and test it, just click here. You can see the build model here. This button. But remember, before you click the button,
can you?
Okay, so this button.
Okay. Better 啦，我。
Click this button. But remember, before you click this button, ensure that you have the dongle plug into the computer. Otherwise, I can give you guys a demo. You will receive a error message like this. Okay.